A very good morning to all dear students. In this today topic, we are going to discuss about our solid state physics, advanced solid state physics. We are going to discuss the topic. The topic name is we are going to discuss about the spontaneous magnetization. Very important concept, very interesting also. If you understand the depth manner, we can able to understand what actually the spontaneous magnetization means. Understood? Here we will try to discuss about the spontaneous magnetization. Spontaneous magnetization. What is meant by spontaneous magnetization? The name itself indicating some specification. What is meant by spontaneous magnetization? Spontaneous means what? Suddenly. There will be a sudden change in the magnetization or a magnetic property of any material is going to take place. But how it is possible to take suddenly? Is it possible suddenly? So actually, according to the law of physics, there will be no sudden change will be happen. There will be always from a smaller, lower change to the higher form. Lower form to the higher form at a particular point. That is called the transition point. The change will be take place. Or in any medium, definitely the temperature is taken very, very important and crucial. It is called the transition. Why it is called transition? This transition is it is trying to change of the state of motion of particle from the old to the new, or whatever the earlier state which was there, it is not there. Means new progress will be taken place. What is the form of the magnetization state? So simply, spontaneous magnetization is suddenly changing the magnetization properties of the metal is going to take place. So before starting, we should know some ferromagnetic properties of a material or ferromagnetic proving. I will try to explain these theory. Very interesting. We will try to discuss. But here we will try to discuss about the ferromagnetic material. How ferromagnetic material are going to behave. And we very well know what is meant by ferromagnetic material. The definition of ferromagnetic. Let us see now. So ferromagnetic materials. So here now we are having the ferromagnetic. Ferromagnetic material. So what are ferromagnetic materials? If any material are taken in which the domains are there, in which the dipoles are present. Due to the presence of dipoles, what will happen? Definitely, we are going to get some changes. We are going to get the magnetization of a material is going to take place. Understood? So that's why what happened? We are going to get the magnetic properties of a material is going to get. So ferromagnetic materials are type of materials which will apply external magnetic field. External magnetic field when you are applying, what will happen? It will try to move along the direction. It does not oppose. If you take a material here, inside the domains, different domains are there. So here what is the property actually here we are having? If you are taking the ferromagnetic material and we are applying some external magnetic field. If suppose if you try to take a paramagnetic material, what will happen? When you are applying external magnetic field, definitely we are going to get what? We are going to get the repulsion. Means it will try to expel in the diamagnetic material. It opposes the magnetic. Whereas ferromagnetic, we are having the domains. It does not require external field. It does not require any external field. Understood? Though you are not applying external magnetic field, it will try to generate its own magnetic field. Suppose iron, if you try to take, it does not require to generate separate. It has properties. So major ferromagnetic materials are magnets are used as a ferromagnetic material because it does not require to make any changes to the material. As usual, what we are taking ferromagnet directly if you take and keep before the pins, iron, copper pins, and it will try to attract all the particles before it. Understood? The attraction will take place. Sir, why sir attraction will be take place here? Means we should understand the attractions are taking place due to the property of a ferromagnetic material. So here if you understand this, then we can easily understand what actually the spontaneous magnetization definition, concept, graph, Curie temperature, Curie law also interlinked. Very interesting topic. So here what happened, we have discussed like this, I am applying magnetic field. So here what happened, magnetic field, whatever we are having, please understand, magnetic field, whatever we are having, it will try to help to extend more magnetization. If it is having 80% magnetic power, example, already it have, but external magnetic field will try to give more energy to the internal domains. Understood? Like that we are having. So ferromagnetic material having domains. We are having the domains. Like each arrow is called a domain, and this arrow how much number of atoms we are having? Nearly 10 power 9 to 10 power 15 atoms. Each domain contains. See how interesting each arrow or each is doesn't got arrow but domain or domains. If you are taking code, it's called the domains. We are having 10 power 9 to 10 power 15 atoms are present. And this each whatever we are having each number is 10 power 9 to 10. And to measure whether the material is having the high number of magnetic property or it is entirely dependent on how many number of the domains are there. So how to calculate the how many number of domains are there? It can be intensity of any magnetization can be calculated depending on the area. So how much amount of magnetization is present in the magnet can be determined by the how many numbers of moment, how many numbers of domains are present. Suppose we are having material here. So how many number is there? Which number of magnetic moment? How much amount of, how many number of magnetic moments are present in that? Depending on that, we are getting the magnetic moments. Understood? Like that, we are having the different forms, different contents we are able to get in the total overall the what ferromagnetic materials. Understood? Like that, we should try to understand what are the changes are taking place in the material of the ferromagnetic materials. Understood? Domains 10 power 9 to 10 power 15 atoms, how many number of atoms are there? Here what happened? The concept I will try to come here. Each atom generated before applying it is already in the ferromagnetic material already it is having the order state. It is already having the order state. When you are applying the magnetic field, some randomness nature will be take place at a particular temperature. And ferromagnetic metals are the independent of temperature. Independent of temperature, it does not depend on the temperature. And it will occur only when liquid, gas, and solid were. It is occur only in the solid states. Ferromagnetics are majority of the materials of ferromagnetics are the solids. Why solids we are having? Because the arrangement of molecules are in a regular manner. So concept number 1. Now we are going to discuss another, that is concept number 2. What are paramagnetic materials? If you try to take a ferromagnetic material, if you try to apply some heat, what will happen? Let us now try to see what is going to happen. I hope you have followed this concept number 1, that is ferromagnetic material. That is the properties of ferromagnetic materials, and they are highly magnetic. Now, what is happening is spontaneous magnetization is going to be. What is meant spontaneous magnetization? Spontaneous magnetization, before that, we will try to discuss about the Curie's law. Psi equal to C by heat. C is the Curie temperature and T is in absolute temperature. So susceptibility, that is the sign symbol we use. Psi is equal to C by T. Understood? So that is nothing but the what Curie's law. And what is Curie's Beast law? Curie's Beast law. Curie's law is nothing but same, but we are using the two variable temperature. Two variable temperature. Variable is what? We are using the two different type of temperature we are using. That's why it's called Curie Beast law. Now what happened is spontaneous magnetization. Spontaneous magnetization is entirely dependent on the Curie's law or Curie temperature. Any material, if you are trying to apply some sort of external temperature when we are applying to any material, what is happening? Some sort of disturbance to you. First, by applying, I will try to discuss the definition. At a particular temperature, I am writing generally, I will write notes on particular T where paramagnetic or any material converts into ferromagnetic material. And at particular temperature, there is a sudden change wherein metal convert into the ferromagnetic suddenly. Any material is what? This method generally we are taking the paramagnetic. So here what happened at a particular temperature, what happened at a low temperature and high temperature. Here what happened, we try to discuss the low temperature, low T and high T. If the temperature is very low, what happens? All the atoms or arrangement are taken in a regular manner. And when the temperature is very high, what happens in classical theory, in quantum theory we have discussed, whenever the temperature is rise, what will happen? Whatever the dipole moments which are present inside the material, they will start in thermal agitations. Please note on thermal agitations or thermal fluctuations. So these thermal fluctuations will what happen in the thermal. Thermal means heat. Fluctuation means motion of a molecule from one form to the another form, or they are moving in the different forms of energy. That is called what mark? That is called the fluctuations or thermal agitations. Thermal agitation means whatever the atoms or molecules which are arranged in a regular manner, when we are applying the external heat. What will happen when we are applying the external heat? The molecules are trying to change its rest position and they are start colliding. These thermal agitations will try to disturb the molecule, and will try to change the rest of the motion of a molecule. So that is called the surface. And here there is a low temperature and high temperature. What does it represent, sir? We get out. So here very interesting concept is that low temperature where the material or existence as a ferromagnetic material. Ferromagnetic material. But when you are applying the temperature, to a ferromagnetic material, means we remember all the arrangements are taken the moments in the good number of order manner, the low temperature where Tc is greater than T. Where we are having the critical temperature is greater than T, then what will happen? Then we are having a good number of arrangement of molecules without any thermal fluctuations are present. Such that whatever the external magnetic field you are applying, it will try to take that also and it will apply inside the material, and more magnetization is going to generate for the ferromagnetic materials. Understood? So now first concept, second concept. Now we are discussing about what now we are discussing the low magnet and low temperature where magnetic moment of material does not get changed. There will be less fluctuations and the material can be converted or it will be sustained as a ferromagnetic. But spontaneous magnetization is what happens when you are applying external heat. Please try to note that. External temperature. Heat is temperature only, but difference of temperature. Heat. Here, external temperature when we are going to apply, what will happen? Definitely it will try to affect the total magnetization of the material. Understood? So total magnetization of the material is going to change because whatever the magnets which are in a regular manner, whatever the magnets are in a regular manner, what will happen? They are trying to change the rest of its position. They are trying to change the rest of the position of the molecule. Then, whatever the orientation was there, in the regular manner, they are getting random. See, the domains are changing. So, what is happening, sir? Difference between this ferro and the conversion is taking place. The sudden spontaneous magnetization is going to take place. Due to this, what happened? Whatever the generation, whatever we are going to generate, that material are going to change from ferromagnetic material to the paramagnetic material. That is called a demagnetization. We are having the adiabatic demagnetization also have the degree. But how we are going to take adiabatic demagnetization where material where applying some external heat to the ferromagnetic material, there will be sudden change in the material. That sudden change is called the spontaneous magnetization of a material. Understood? So this is actually the spontaneous magnetization. Sir, how to define the equation, how to define the expression is orally we can able to explain now about the. You please note down the key part, then I will come to discuss about the expression part of the spontaneous magnetization. Now let us discuss about the expression part now. I hope you have written. No. Here we are going to discuss about the one graph. Then I will try to explain about you what the difference. This is called Curie temperature. This is called Curie time, xi, and time. What is the origin? What is it? Curie's law. Curie's law. Understood? Like that, we are having the different type of magnetization. Now, let us discuss about the expression part here. Here we should know here very important thing in the spontaneous magnetization. In order to explain the spontaneous magnetization, we assume that there is internal molecule. What the base saturation assumes to get the spontaneous magnetization, we assume there will be internal. What is internal? Internal is nothing but the which is present inside. Understood? So that's why internal molecular field. Internal molecular field. Molecular field or exchange field. You can also call it an exchange field. Why it is happening? What are the characteristics are present to assume that the molecule is having the exchange field inside the material at state. So exchange field acting on the dipole, understood? That is HEX. HEX equal to H plus lambda m. H is what? H is nothing but the how much amount of temperature magnetic field. Lambda is the susceptibility on size of a particle. F H is equal to nothing but what? Internal molecule field. We are going to observe. Lambda was least constant. Lambda symbol is for the not susceptibility. Here we are having the least constant, independent of T. That is does not at all depend on the temperature. And H is the magnetic field upper. Now equation number 1 and equation number 2 is nothing but M pi HEX C by T. Equation number 2. From simplifying equation 1 and 2 is short we can write. Does not require to along here. By simplifying 1 and 2, what will happen? We are going to get lambda first is equal to C by T. Not M by T. First we get the M by T. Magnetization plus magnetic field. It is equal to E by T minus E lambda. That is equal to C by T into T. So the third equation represents what? The third equation represents actually the change of Curie temperature. It is called transition temperature. Understood? And if Tc is greater than T, means the Curie temperature is greater than T, it is called very important one. It is called spontaneous magnetism. Spontaneous magnetism. To get the material spontaneous, definitely the T should be greater than T. This is nothing but the critical temperature or Curie temperature where the substance is converted suddenly to the spontaneous magnetization is taken to place. And when it is below, there will be no change. When Tc is less than A, no change. No change means conversion to paramagnetic field. Conversion to the paramagnetic temperature. And when both are equal, this is what the Curie temperature. That is not described. So here what we have looked at how actually the changes of material from one mode to the another mode is actually going to change. So like the graph we are having Curie law and Curie temperature, how it is dependent or independent. So what is the conclusion here? As the T is increases and the temperature increases, there will be a more thermal agitation. As the temperature increases, what will happen now? There will be a more number of thermal agitations are going to take place. In such a manner, it will try to disturb the motion of the molecule. As the T increases, thermal energy and the randomness will increase. Understood? As the spontaneous magnetization starts to exist above the temperature, if we cross the Curie temperature, it should hail in the Curie temperature. T equal to Tc, that is called Curie temperature. Which would T equal to Tc is equal to the Curie temperature. T equal to Tc is called the Curie temperature, where the material can have what it can have the Curie temperature. But if it is crossing, the spontaneous magnetization is going to take place. The material can be converted from ferromagnetic to dielectric, because T should be not be greater. T should be always be less than, there will be no change. The metal can be, if paramagnetic will be there, and if you are then ferromagnetic will be there. Will be no change. Understand? Like that, we should try to understand what are the changes are going to take place in the material medium. Understand? So now we will try to discuss the conclusion class. To please try to note the this equation. So overall, what we understand now, a very interesting topic we have discussed today, that is spontaneous magnetization. So what is the conclusion here? What we understand from the overall is nothing but. So what is meant by ferromagnetic material? Any material if you try to take, they are already having the existence of magnetic properties of metal. Understood? That is called ferromagnetic. Means it is have own. It does not require any external agency outside from outside to exist with the ferromagnetic or not. Whether if you compare non-ferromagnetic means what happens, it does not require that much. Because the dipoles are easily arranged, it's not we discuss in the time. And we also discuss about how actually it is going to happen. What is spontaneous magnetization? Spontaneous magnetization is what? There is a sudden change if you are crossing the temperature, below temperature, above temperature, at a particular temperature. That is called Curie temperature, where constant of value will be there. That is called a ferromagnetic. If you are applying more heat to that material, that ferromagnetic material can be converted into the paramagnetic material. That is called demagnetization. D means what? Reverse. The magnetic material whichever we are having, they are converted into the demagnetized. Demagnetized. They become reversely. That is called the demagnetization. Is going to take place inside the material. Understood? Like that, we are going to have the different number of topics we are having. And definition we discuss low temperature. In low, what happens? Whatever the arrangement, low or normal temperature. All the arrangement of molecules are in regular manner or regular fashion. But when the temperature rises, it will cross the Curie temperature. Greater than Curie temperature, what will happen? There will be a thermal agitations are going to take place inside the material. These thermal agitation metals are trying to create the thermal fluctuations. Understood? Due to that, we are not able to get the exact number of the molecules for the requirement for the conversion of one material to the another material. This is the fact number 1. Fact 2. And what is Curie temperature? Lambda equal to C5 is a Curie temperature. What is the expression you can able to this internal? So we what we have done, we have calculated there will be internal molecular field. Internal molecular field, that is called the exchange field. Understood? Exchange field, how much field we are applying? H plus lambda into m. Understood? Like that we are able to get the simplification of the Curie temperature and spontaneous magnetization. So conclusion is overall we are having T should not cross. If it is a Tc is greater than T, there will be a magnetization technique. You can get this parameter. No change means it will remain same. There will be no change. Whatever the material is there, it will remain same because it is below the Curie temperature. And what is Curie temperature? T equal to Curie temperature. So if it is satisfied this condition, then we have the material will remain same, does not change. And so you can change the paramagnetic or any other. So condition is what? Spontaneous magnetization will only take place when we rise the temperature of the ferromagnetic material. That is called the sudden change. That is called spontaneous magnetism. This spontaneity is taking place due to the domain theory. So different domains, whatever we are having, due to thermal agitations, they will try to align to different directions. And they will try to cancel each other and they will try to convert the ferromagnetic to the paramagnetic material. Understood? Like that, we are come to know about the today topic, how actually the changes are going to take place. As the day increases, thermal energy requirement spontaneous magnetization stops. They exist above the Curie temperature. As the low temperature area of atoms are increasing temperature, result disorder becomes a demagnetization. Understood? Like that, we are able to understand what is going to happen. And ferromagnetic arises when lectures in a regular order. So orally, in this class we have discussed about what, ma'am? We have discussed about what actually the spontaneous magnetization is, their definition and background, ferromagnetic material background. We have discussed what is domain and what is Curie law and Curie-Weiss law. Curie-Weiss law is used about what? It will give the difference of variable temperature, not one temperature, initial and final. Then it is called the Curie-Weiss laws taken in the consideration. Understood? Like that we are having, and orally we have the conclusion equation. So orally what happened? Why we are going more advanced from classical to the quantum. In classical, what we have discussed in classical theory, like we just explained that atoms are molecules which are moving having permanent dipole moments and having the dipole moments are fixed. But quantum theory said that all the whatever the molecules having the dipole does not have the same state. That's why it is going to change. And due to the change of this, we are able to get the different forms of formulas and laws and rules. That is Curie law, Curie-Weiss law. So like that we are understand. So what we understand, how we can convert the one material into another. In next class, we will try to discuss the another topic. Thank you all of us for listening. We will meet up.